Alright. Hello everybody. Dirk here. Once again, welcome to my dungeon laboratory. Just do a video here on this this new synthesizer that I put together here. Basically that anybody can build. This is your basic keyboard synth. Basically everything that you need is in this box. I explained it on my my preview video already. Just want to go through basically, what it is that you need, which basically comprises of four components that you would need in order to build yourself a standard keyboard. So I kind of had this drawn out a little bit. It's kind of crude right now. I still got to work on a bunch of stuff because eventually this will be a part of this. I'm not quite sure how I'm going to do this yet. I still have this whole section right here that has nothing, so I'll probably end up building another box of some sort, and maybe like a case to where I can, just slide this keyboard in and take it out, because basically I'm just using the keys on here. There's nothing in here. It's just the keyboard set up right here. These three input jacks right here, these banana jacks that feed into the box here, and that's about it. But yeah, that's later. Getting away from the purpose of the video. So anyway, yeah, four components of what you need. So basically, you have your 1 volt per octave oscillator, which is this whole thing up here. It seems kind of complicated, but it's really not. Fortunately, I don't have. Let's see if I can get some of the. Well, there's one part of it. I'm not quite sure where the other part's at. This is a secondary module for your square wave, which is right here. It's basically marked as pulse. It's a square wave essentially. Yeah, it's pretty simple. It's two ICs. Let's see here. Oh, wait a minute. Oh no, I'm sorry. This is the actual part of the oscillator, which is this chip here, which is the CEM3340. There are equivalents, NTC equivalents to this, because these chips and these ICs are like 25 euros a piece. I'm not quite sure what that would be in dollars. Might be 30. I'm not sure, or less. Basically, these were used back in the 70s, I would say 70s and 80s. Discontinued and then revived back once again in 2016 due to popularity. So there's an actual, it actually says in the IC revision 2. Because this is an all-in-one 1 volt per octave oscillator, and it gives you, I'm not going to explain it on that, it's easier to do it right here. It gives you three basic waveforms, which is basically your square, your sawtooth, and a triangle. With some additional circuitry, you can get a sine wave output, and it sounds really, really nice. This is probably like the best sine wave I've heard so far. Better than the one that's up there, which is also 1 volt per octave oscillator. It's basically these two sections right here that make up the oscillator. And then, as I was saying, there's an additional circuit inside here, which is two ICs and an op amp, which gives you more of a variety with your square wave, which is pretty cool. Which is these three switches down here. Where you can do octave selects. You can switch the polarity between plus and minus. These are bipolar power supply circuits, basically, which have a plus and minus voltage. Most of the time, the op amps are plus minus. You can run op amps on a single, positive power supply. Yeah, I don't know. It kind of depends on how you want to go about, building, synthesizers or yeah, modular synths and whatnot. If you want to do bipolar or single rail, I think Euroracks, I think they're like +5 and ground power supply. Not 100% sure. So yeah, it's kind of, you know, how you want to go about doing it. I started off with a, you know, doing the single supply circuits and whatnot, 555s and whatnot. But once I started getting into this, it started getting a lot more interesting. Probably a little more complicated in the beginning, but once you build enough of these, it's pretty simple. Anyway, this is probably the best oscillator so far that I've built. You know, it's got everything that you need: coarse, fine, linearity, exponential, and this is under your PWM, which is your pulse. It's got a sync feature. It's got 3 inputs for Lin, Expo, and PWM CV control voltage. It's got your 1 volt per octave input, which is basically a control voltage input, and I added in a second CV just for fun. And this potentiometer up here is a pulse blend, so you can either turn it all the way to the right, and it's just a basic square wave, or you can turn it all the way to the left, and it's basically a blend of this square wave feeding into that additional circuitry that I was talking about before to give you more variability. Variability? Is that even a word? I don't know. My brain's kind of fried from work today. I apologize. So there's your oscillator. Great. So okay, what do you need in order to make it sound like that and not just play the whole time? Well, you need something to be able to play it. So there's a couple of options. You can either build a sequencer, like this one, for example. It's really simple. I believe it's a 2, 4, 6, 8, 10-step sequencer. It's got some additional circuitry. This is a little bit more custom. It's got the 3 outputs here, and then this is just a ground, just in case. Because generally, when you have more, you know, circuitry and you want to combine things together, they should all share a common ground. But typically, I feed everything from this power supply right here, and this gives ample current. It can power everything that's right here, no problem. Anyway, so this is one option, a sequencer, or you can buy a sequencer like that, which I bought. It's €200, the Arturia BeatStep Pro, really cool. So it's got basically 2 64-step sequencers and, well, basically trigger outputs for drums. You know, if you have like a whole drum setup, excuse me, which I'll eventually have. I only have the one drum up here, but you can set up oscillators and whatnot in order to make different drum sounds. That's kind of how it is. Like, for example, this right here, I know you can't really see it not well. Oop, there goes something. This is basically a white noise generator, and you can basically make like a cymbal or a hi-hat with that. So that's an example, and basically you can make different drum sounds with this: wood block, toms, bass. You know, and that's just one thing. And yeah, it's pretty versatile. It's pretty cool. Anyway, so the other option is, well, you can make yourself a keyboard like this. Now, obviously, this wasn't like this. This had a keyboard matrix inside here with its own circuitry, you know, and it was basically its own keyboard. A bit of the components like that right there is from this keyboard. And I basically stripped this all down, took everything out, and put in a single line bus. So basically, each key basically is just a switch. That's all it is. It's a switch that runs through a set of resistors, and that's basically about it. Trying to think here. Hang on. Guys, give me a second. This will probably be a bit of a long video, but if you have any interest at all in this, it might be beneficial to you. And I would suggest going to this website here. Let's see if I can find it really quick for you. Where is it? Oh, I never really think about my videos. I apologize, guys. bear with me here. It's not really it. Where's the 1 volt? I'm trying to look for the 1 volt per octave keyboard. Oops, didn't want to click on that. I apologize, but it's here somewhere. I'm not gonna kill you guys doing this. Wait, no, there it is. Right. Probably can't read that too well. And it's a single bus 1 volt per octave keyboard. And that's basically, so if you can see the circuit, the circuit right here. If you look up here, I know my camera's not the best. Bear with me. But basically, this is the keyboard right here. So you got your switch right there with the resistor, and the bottom bit here is just is the bus, and the voltage is divided, between these resistors to give you your individual notes, and then it goes down to ground. Hence, with this, you can't see it very well. There's your ground, there's your bus, and this is your your resistor chain right here, and that's what's feeding into this right here, which is a keyboard controller. And if I press some buttons, you see these LEDs light up. One being a gate, one being a trigger. I don't really use the trigger at all, but the gate is something that you really want to use. So as you can see that, and you can see the trigger lights up only briefly, where the gate lights up a lot more. It has a lot more of an output voltage, the gate does. And this is a triangle wave, by the way. I can put this on a sine wave. Sine wave is quite nice. You guys are interested in that? Now, I know I'm using a crocodile clip. I need to clean out this this banana jack. These are kind of cheap. They're from China, so sometimes you have to bore out the basically the input socket with like a 4 mil drill bit. Anyway, so here's your 1 CV, and your CV is going over to your 1 volt per octave on the keyboard setting, which is basically just control voltage. Doesn't really matter. It's basically the same input as a control voltage would be. So as you can see, CV1 over here. These are your inputs from the keyboard, and then you have your gate. So what is the gate doing? Well, the gate's going down here. Oh, I'm sorry. I might be getting ahead of myself. Wait a minute. No, I apologize. I need to fix this a bit. This is actually a separate circuit right here, so this line is wrong. It needs to go over here, and I need to work on this still. Anyway, the gate's going over to this section right here, which is an attack decay generator. So basically what that's doing is it's producing an envelope. It almost looks like a sawtooth a bit. If I can represent that for you guys. Once again, bear with me. So yeah, it's coming along. It generally shoots straight up, and then it kind of curves down like this. It's not exactly a sawtooth, but it looks like it in nature. And you can vary. This is basically your attack right here, and this is your decay. That makes sense, yeah? And you can vary that attack decay with these potentiometers, this being attack and this being decay. So right now, it's got a lot of decay on it. Turn it all the way down. Or you can turn that all the way down. So it will only stay on as long as you press the key, and then it just turns directly off. But if you put some attack on there, or we can put some decay on there, so you see how that kind of works. There are some other controls on here, but these aren't necessarily what you want if you want to be able to use it. It has a switch here for a manual gate or an output level. And these are all on this website here, which is Music from Outer Space. I learned most of the circuitry from here. It's all straightforward, great schematics. It gives a full description of how everything works So feel free to, check out the website, look at it. If you're interested in building things like this, I would highly suggest it. I will suggest, for beginners, I will suggest some other things on here before you get into something like this to get your feet wet. Anyway, so let's get back at it. So, okay, here's your, so this is your in, this is the gate that comes from your keyboard controller into the input of your attack decay generator. The output is going over to here, which is a voltage controlled amplifier. You need to be able to control something. You have to be able to have something to where there's no sound playing, right? Otherwise, it's just going to keep doing that unless you press something else. For right now, it's off. A voltage controlled amplifier is nothing more than a potentiometer, basically, except instead of you controlling it, this module is controlling it, and it's controlling it with its control voltage. I have it into this mod right now, this modified through this pot. So if I see that, so now there's nothing. It's pretty quiet for what it is. I would suggest using a shielded cable for certain things like this. That way, other things aren't really affecting it. So I do have my amplifier up fairly loud. So yeah, you don't want to be able to hear that sound. You only want to hear the sound when you're actually playing things. But that's all the voltage control amplifier is. It does have another CV input, so I could put this essentially into here, and it will do the same thing. It just has an in and out, and that's it. The in is coming from the actual oscillator, and the out is going over to the amplifier. And I would suggest building an amplifier of some sort. The LM380 386 is quite good. I have one in there, which comes down to these two speakers, and these two speakers have a dual LM386 inside them as well, so it's plenty loud. I'm not sure how loud it would be without an amplifier, but I would suggest having at least an amplifier and maybe a mixer. That's what I have up here. It's a really simple mixer. It's got banana jack inputs and RCA, mono jack inputs, potentiometers, and, well, this is basically an LM386 with delay. And that's all that is, so. Which kind of spices things up a little bit. But yeah, that's essentially what a basic, synthesizer comprises of. These four components, and some way to actually control it instead of using potentiometers. I say it's simple because anybody can build this. If you want to learn how to do stuff like this, all you gotta do is learn how to read schematics, get the parts, get your bits and pieces, soldering iron, whatnot, and carry on and learn about this stuff. I still make mistakes nowadays. I got quite good at troubleshooting and kind of knowing how the circuit's supposed to work and what it's supposed to sound like. It's relatively easy, but if you want to, let's see here. Something like this. This is something that I built right here. This is the first thing that I built, was this experimenter board. And this guy, Ray Wilson, he's the creator of this website. He's not with us anymore. He had died a few years back from cancer, unfortunately. But wonderful guy. I'm grateful that he put this on here. I learned so much about analog circuits, and what better way to learn about analog circuits is to build something that you can play with. It makes cool sounds. Even if you're not a musician, you can make lots of cool sounds. It's really neat. I'm not a musician, and I love doing this stuff. It's great. And you can learn how to do this stuff, or you can just buy the boards from the website or from other various websites. Then you get all your components and put it together. You can still pretty much learn it, and it looks a lot better in the end. Build yourself a case. You can do that too, or you can go like with a Euro rack or something like that and buy the modules and whatnot. But you're not really in my opinion, you're not really learning how the circuit works. I'm pretty sure you can go to the website and it tells you how to. Alright, well, I guess I can only record 20-minute videos. I apologize for that. I didn't realize that. Anyway, what was I on about? Yeah, you don't really learn a whole lot from from the websites. It's kind of better to build it yourself. That way you get a taste for it, and just general circuit building. It doesn't have to be this; it can be anything, But that's kind of how you learn. I learned, I started off with high voltage stuff, 555 timers and other things like that. Drive circuitry for high frequency transformers. Got kind of bored with it, so that's why I started building other oscillator circuits to make noise. Atari Punk console is a good way to start, or multi vibrator circuits using transistors, things of that such. Can get you in there. And if you want to learn analog circuits, I really suggest this right here, which is a synth DIY experimenter board, which is basically this box right down here. It doesn't have everything with it, but it's mostly all there. 2 oscillators right here. You got 2 LFOs, 1, 2. And this is a voltage controlled filter. This is a micro sample and hold, which is really cool. Micro sample and hold, basically, essentially what it does is, say you feed a square wave into here, and then you have these control voltage outputs. And basically what they do, once again, get out a piece of paper. I'll show you guys. So let's see here. So there's a square wave, right? And basically what the circuit does is it kind of, you kind of see that it kind of steps it up and steps it back down. So it's, I know it's kind of hard to explain. I would hook this all up for you guys, but I'm going to save that for another video. I'll kind of explain, the different circuits and kind of what they do, if anybody's interested in that. Anyway, what else do I have on here? Then I have this. I explained this before. This is a custom echo module right here, which has control voltage inputs, and this is the super echo. You can drive this all the way to where it just completely distorts. Sounds really nasty, but if you do just enough, kind of like in that area, not all the way here, but somewhere. I'll explain this in another video. But you can get some crazy echo modulation with this thing. It's really cool. This is probably the only thing that's digital. These ICs that I use in here, I forget what they're called, but it's basically analog and digital in one IC. Pretty intense. And yeah, this is basically the experimental board right here, which is on this website. And it goes through all the different things. Your oscillator, your voltage controlled filter. They're all right here. Voltage control filter, amplifier, your LFO, attack release, envelope generator, white noise, things like that. I also built this, which is the weird sound generator, which is also really cool. I built a lot of these things on here. Or there's lo-fi noise boxes as well. I also built stuff like this, the Alien Screamer. I'd suggest checking out the website or going to his YouTube channel, which is right here, because he demonstrates quite a bit of these when he was still with us. There's something like this right here. So, if you wanted to get into things like this, I would suggest building starting to build one of these DIY experimenter boards right here, which is basically this right here. And then build yourself this right here, which is a mini mixer 1 amp or 1 watt amp, which is essentially what that is up there, minus the echo module. And that'll get you started, And you can, it'll take you a while to build all these, to build this. So this took me a couple months to build this. And I had this over here too, but I'm taking this apart because I don't really use this as much. But I do like the modules that are in here. I took a couple and put them in here. Basically, this and this is from this over here. And it's got a couple goodies that I want to put on the panels and put on my actual rack that's up there. Yeah. That's kind of things to get, if you want to get started in analog circuitry, that's a way to go about doing it. Or you can build something like this. It's not complicated. This oscillator is not from that website. This is actually from, let's see here. Trying to think. I think this is from Thomas Henry. I think the website is called Birth of a Synth. I'll try to put the links in the description so you guys can have a look for yourselves. Yeah, but this is quite cool. I do like this quite a lot. It's really easy to build. It took me about a week altogether. I'll spend about 3 or 4 hours down here during the weekdays, and on the weekends I'm basically here the whole the whole day working on this stuff, working out bugs, and then putting it all into a box and whatnot. So yeah, it's pretty cool. So yeah, that's the introduction, what you need, and where you can get started either with this or something like that down there. As I said, check out the website, get yourself started, or if you're already experienced, there's quite a lot of cool stuff on here to kind of keep you going if you like building stuff like this. And then basically my next video is going to be kind of going through the waveforms a little bit more and how this kind of works up here, what you can do. And then after that video, there'll be a separate video on how to make some different sounds. I kind of learned how to make different sounds just by experimenting. You can make bells or chimes or you can make other sounds from different instruments using this with different inputs and whatnot. And yeah, we'll carry on with that. Yeah, if you have any comments or you want me to show you something in particular, or you're interested in whatever, put them in the comments down below. I will read them all and I will give you a response. So yeah, thanks for watching, guys. Cheers.